Just leave it like this right now. Change the description. Matrix. Just for the so yeah, correct. Or yeah, because if you yeah, so the way I think about angle, I always start with some reference point. In case a good reference point for the problem. That's right. Yes. And I think about how do I get this? How much? So in this case, this vector right here, that's the ending. That's where we want. You can only rotate counterclockwise. First, you rotate from horizontal. Exactly. So that's 85. So that's an 85. Where if you want to rotate into here, you have to rotate 180. So 180 is a full half rotation, not a full half rotation. And then from that point, right, then you rotate an additional 60 degrees. Which is the given. Exactly. So like going the given one, yeah, the 85 is from everything there. Yes. So in the second case, Yes, yeah, that is. That's how that, to me, that kind of, because I'm a very visual person, so I like to see kind of the pipeline. Yeah. And that makes a lot of sense. Thank you. Yep. This one, I was looking at That's all got costs. Okay, it's 4 o'clock. Let's go and get started. All right, good afternoon, everyone. How's everyone doing today? Good. Okay, so it's the day before the midterm, so our midterm is Thursday. My plan for today is let's let's finish up our MATLAB tutorial. But obviously, we're not doing any MATLAB on the midterm on Thursday. But starting next week, we'll be doing kind of a big shift in the class in terms of using MATLAB to solve a lot of our optimization problems. So we started this on last Thursday. So we made some pretty good progress through the tutorial. So we almost made it through if statements. And so today I wanted to finish that up. I want to talk about for loops as well. So for loops is going to be an important part of our optimization algorithms, and then do a couple of examples with you guys as well. Okay. So the point of the examples today is we're not going to be programming. I would say they're not real optimization algorithms. You'll see that they're kind of very dumb ways to find optimums. But what we're going to do in the example today, all of our other codes are going to follow the same structure. We're going to have a lot of the same programming constructs, a lot of the same syntax, a lot of the same kind of structures of the code. So I want to use those examples as a way to kind of illustrate kind of everything that we've been talking about. And also to kind of give you a little bit of a preview of where we're going. All right, any questions before we get started, either on MATLAB stuff or on the midterm on Thursday?
Any questions
The homework solutions?
sorry, somebody got it.
No, not gonna go. So if you have questions on that, you can email me or come to office. I have office hours tomorrow, 5:30, and then Thursday at 1. All right, so let's go ahead and pick up where we left off. Okay, so last time, we kind of introduced the idea of using MATLAB. We went over a lot of the basics, and so we talked a lot about defining variables, using variables, and where we left off was if statements. So if statements are a very important part of optimization programming. What if statements allow you to do is that they allow you to have your program do different things depending on certain situations or certain conditions. Okay, and that's going to be really important because a lot of the algorithms that we're going to discuss, basically the logic is going to be kind of like a branching path, and so depending on where you are in the algorithm or depending on kind of the most optimal point at the current time, you may choose to do one type of calculation in your algorithm, or you may do another type. And the best way to do that kind of programming is with if statements, right? So the general structure of an if statement is that you say if, and then you give some kind of conditional statement. Usually the conditional statement is some kind of, maybe in some kind of inequality or maybe some kind of equality check, right? And so that's going to return either true or false. And so if that condition returns true, then you're going to go inside the if statement and do this. But if it's false, you're going to just ignore the if statement. We did a few examples of this last time, and so script that we were working on. For a while, talk about else if. So else if is a way for you to write a program to check multiple different conditions. Okay, and so maybe you want to check one condition, maybe it's false. Maybe you want to check another condition to see if it's true. Right. So an else if statement is a way to do that. So I believe that was the last example that we did before ending on Thursday. Right, and so one example for this is, is right here. Okay. So the last piece of code that we wrote is if. So we have this variable called needs correction. So if the value of needs correction is less than 5, then we set the value equal to 5. Else if if the variable needs correction is greater than 11, then we're going to set its value to 11. If both of these statements are false, then we just okay. Let me go ahead and change this value. So let me go ahead and change it to 9. Okay, so based on the value needs correction. So let's kind of run through the logic of the if statement. So needs correction has an initial value of 9. And so if we go to the if statement, first thing we're going to check is if the value needs correction is less than 5. So in this case, the value of 9 is not less than 5. And so this first part here is 1. And so if this first if statement here returns false, then we're going to ignore every kind of else if statement. Okay. Next thing we see here is that we check else if needs correction is greater than 11. Once again, we're checking another conditional here. So we're checking the value of needs correction and we're seeing it greater than 11. So right now the value of needs correction is 9. That in fact is not greater than, also is equal to false. And so if both conditionals on the if else if statement are false, then we're going to ignore everything in the if statement entirely. And so we kind of just ignored everything in this code right here. And so if I run this code, you're going to see that the variable needs correction is still going to have a value of 9. Okay. So we're going to run it. Indeed, we can see here in the workspace that needs correction has a value of 9. Okay. But let's try with a different value and let's see kind of what happens. Okay, so let me change the value of this needs correction variable. Let me change it to 13, which is what we had before. And so if this needs correction variable has a value of 13, we're going to check the first conditional here. If needs correction is less than 5, we plug in 13 for this variable here to not less than 5, and so this is going to be equal to false. Okay. So just like the first example here, this first part here is going to be completely ignored, because the conditional within the if statement is false. But then the program comes down and it sees that, oh, we have an else if statement here as well. So the next thing we're going to check is that we're going to check if the value of needs correction is greater than 11. And we plug in the value of our variable here. 13 is greater than 11. And so this part here is going to return true. And so if this part here returns true, then we're going to execute the lines of code that are within the statement. And we only have one statement there, which resets the value of needs correction to 11. All right, so I'm gonna go ahead and run this code, and then based on kind of what the value of this is, we're gonna see our value for needs correction is gonna be. I'm gonna go ahead and run the code. You can see here that the value of needs correction is indeed 11 because we. Okay, one last example. Let's see what happens when the first part is true. Okay, so I updated the value for needs correction to 3. Right, so once again, we're going to run through this entire if statement. First thing we're going to check to see if needs correction is less than 5. When needs correction has a value of 3, which is what we have here, which is indeed true. And so since this first part here returns true, we're going to change the value of needs correction to 5. Okay. Then we check the second condition. Second condition here is else if needs correction is greater than 11. At this point, actually, so you want to be careful. So remember, MATLAB codes are always read from top to bottom. So at this point in the code, when it's checking this conditional, correction already had its value updated. And so here, needs correction has a value of 5 at this point in the code. Not that it changes the outcome of the else if statement, no matter if needs correction is 3 or 5, it's still going to be false because neither of those numbers are greater than 11. But, I wanted to kind of make sure to kind of point that out. It's kind of a subtle thing. So when a variable's value is updated, it's updated immediately, and every line of code underneath that will use that update. Okay, so even though this has a new value here, it's still false. And so we're gonna ignore this line of code. And so if I run this code, the last value for needs correction is going to be. Okay, so let me go ahead and run the code one more time. You can see here that the value for needs correction. All right, so else if statements are going to come up a lot in our in our kind of our exploration of optimization, because there will be a lot of algorithms where you're going to check multiple different conditions, right? And so you're one condition, if that's false, you want to check another condition, okay? And so else if statements happen a lot. The interesting thing about else if is that you can actually chain them together, right? And so if you want to add another conditional here, you're not just limited to one else. If check another conditional here, so maybe needs correct. Say let's check if it's less than 0, okay? And we can say needs correction. You can have multiple else ifs, you're not just limited to one. And so in fact, there will be algorithms later where we check maybe 3 or 4 or 5 different conditionals in the same if state. Keep going, as many else if statements as you want. With such a simple example, with just checking a single variable here, there's so many interesting else if statements that you can do. But in theory, if you have a more complex situation, you can do. All right, any questions on else if statements? Okay. Another thing that I want to highlight here before we move on to else statements is, maybe you want to combo different conditionals as well. So this isn't in the slides, although I should put in. So maybe you want to combine several, you want to check several conditionals in a single statement. You might remember this from your MATLAB course, and so these are going to be the and operators and the or operators. Okay. So let's say that you want to check 2 conditions before you enter into an if statement, right? So let's say that we find a new variable here, so we'll call it correction 2. So let's say that we're checking its value, we're checking its initial value to 10. Okay. Let's say that we want to check 2 things at the same time. So let's say that we want if and here just to close the if. Let's say that we want to check both to see that if needs correction here is an even number, like if needs correction to even. Actually, the way that we do that is we do mod correction to 0. So if you've never seen this line of code right here, the mod, we're not going to use the mod function all too much. It's really just kind of something that's just kind of niche that we're going to use right now just for the MATLAB tutorial. Not that many optimization algorithms depend on even, but it's kind of a cool function to know. The mod function here basically takes in 2 inputs, 2 input scalar numbers. And what it does is it performs an integer division between them. So integer division, this is probably the first type of division that you learn in kind of grade school. So this is kind of before you learn about fractions or before you learn about. So when you perform integer division, usually what's going to happen is that if your 2 numbers are not perfectly divisible by each other, you're going to have some kind of remainder. Okay. So hopefully everyone kind of remembers that from 5th or 6th grade. And so when you perform division with integers, right? Oftentimes you say, 5 divided by 2 is equal to 2 remainder 1, right? So you divide as much as you can, but you always have some kind of remainder of it. So this mod function here basically returns that remainder. After the. So it tries to do a division with whole numbers as much as possible. But you know, if there's a remainder, then it gives you that remainder. And so let's kind of examine this conditional here, because this is also kind of good practice for practicing what's in MATLAB too. And so what I'm saying here is that I want MATLAB to perform this mod operation, okay? And I'm feeding it two numbers here. So you can see that I'm feeding it, the first variable that I'm feeding it is our needs correction variable, okay? So that's going to be the numerator of the division. The second number I'm feeding it here is the number 2, okay? And so that is one operation. So you know, this operation here, we're taking our variable and we're dividing it by 2, and then we're returning whatever remainder kind of remains after that. Okay. The second part of this conditional is that I'm checking whether to see this this operation here returns 0. Okay. Because if you have an even number, if you divide it by 2, right? Any even number divided by 2 will give you 0 remainder. That's kind of that's one of the definitions of an even number, right? So whether your even number is, you know, 2 or 8 or 528, right? So all of those are even numbers. You divide by 2, you should get 0 remainder. Okay. And so this is one way for us to check if that number is even. And our original number. Okay, so that's one thing that we can check to see if our number is even. Okay. Well, let's say that we want to check something else, right? And so let's say that we not only do we want to check if the number is even, but we also want to check to see, maybe correction greater than 8. So we want both of these things to be true in order for us to enter into the if statement. Okay. Oftentimes, you're going to have situations like this where you need to check multiple conditionals before you enter into an if statement, or before you jump into one kind of path in optimization algorithm. Okay, so the way to kind of combine different conditionals into a single if statement is to use this AND operator. Okay, so if you notice here that in between these two conditionals, so this is our first conditional, right? Our first conditional checks to make sure that our checks to see if our variable is an even number. Our second conditional is, checks to see if our variable is greater than 8. So those are the two things that we're checking. In between them, you can see that I have 2 ampersands. Okay. Double ampersand. Basically, this is MATLAB's way of saying and. And most people would describe it as kind of an and, they call it an and operator. So the way to kind of read this in kind of plain human speak is to say that if needs correction 2 is an even number, and if needs correction, if needs correction 2 is greater than 8, then we can enter into the if statement. So for an and operator, both conditions before and after the operator have to be true to we need both of those conditions to be true to enter, right? So that's kind of what the and is. So and is saying that both this has to be true and this has to be true in order for this entire thing to be true. Okay. Let's check and see, well, let me just put in inside the if statement in this case, it doesn't matter all too much. You know, we're just, you know, trying to better understand kind of if statements and conditionals, okay? And so if both of those things are true, so if our variable here is an even number, and if it's greater than 8, then we can enter into the if statement. Let's check and see if that's true for our current variable. So we have our variable needs correction 2, it has a value of 10, okay? Let's go check these two conditionals. So is 10 an even number? 10 is indeed an even number. Okay. We're going to check if 10 is greater than 8. That's also true. Okay. So since both of these statements are true based on our conditionals, then we're going to enter the if statement. And within the if statement, you can see we're going to set the value of this variable to. And so, you know, by our predictions here, just kind of reading and interpreting this code ourselves, you know, the value of this needs correction 2 variable should be 0. And so it should start as 10, but then once we execute the if statement, it should change to 0. All right, so let me go and run this code. And once again, you know, let's go ahead and pay attention to the workspace on the right here. You're going to say that you're going to see that this variable here will change its value to. Okay, so I ran the code. You can see that our needs correction 2 variable does indeed have a value of 0. Okay, any questions so far on the AND operator? Okay, so let's change this up a little bit. So I'm not going to change the conditionals, but I am going to change the initial value for this needs correction 2. Okay, so instead of an initial value of 10, let's set an initial value of 9 for needs correction. So let's see how that affects our code. Okay, and so with the value of 9, right? So once again, you know, we're going to enter this if statement and we're going to check both conditions. Okay. We can see right away that our value of 9 is indeed greater than 8. Okay. And so that second part there is definitely going to be true, okay, because 9 is greater than 8. But our first conditional here is going to fail because you're going to see checking to see if 9 is an even number. Okay. So if we divide 9 by 2, we should get remainder 0. That's true. But that's not true, right? So 9 is an odd number. So if you take 9 divided by 2, you're going to get 4 remainder of 1. So since this first one here returns false, the second one here returns true. Because we have one false here, then we're going to basically ignore the. And so with an AND operator, everything has to be true in order for you to. And so if I run this code, what should happen is that, you know, inside this if statement, we're going to ignore everything in here. Okay. With the one of the AND operator conditionals is false. And so our value for needs correction 2 should still remain not counted. Okay, so I ran the code. You can see that needs correction 2 is indeed. Okay, so that's how you use an AND operator. So when you have to have some kind of logic where everything has to be true, then you use the AND operator. Okay, and just like up here, you know, you're not limited to just two conditionals. Okay, you can keep adding more double ampersands. And condition 3. 4. You can have as many conditionals here as you want, and in fact, you know, there's going to be algorithms that you can. So one quick example, you know, once we kind of get to algorithms with inequality constraints, you know, one thing you may want to check in an if statement to see is that, you know, maybe you want to check if your code here is producing points that are within your value. And so just like we've seen with the Tucker conditions, all the inequality constraints have to be satisfied. They all have to be true. Okay. So a case with, you know, multiple inequality constraints, you know, that would be good if statement together with an and. Okay. So that's the and operator. The other operator that you can use to combine conditionals together in a single if statement is the or operator. So a double vertical line, if you don't know where the vertical line is, it's typically the key that's right above the enter key. Okay, and so you have to hit shift to hit it. Okay, so you shift that key, you go twice. And so this is what's called MATLAB's OR. It's another way to combine conditionals into a single statement, but the exact logic of doing so is kind of almost the opposite for AND. Okay. Okay. So with the AND operator, we know that every single conditional within the AND operator has to be true in order for. With the OR operator, only one of the conditionals combined together have to be true in order for. And so with the OR operator is interesting. So you can have kind of multiple falses. Okay, so multiple conditions return false. But as long as one conditional here returns true, then you're going to enter into the Okay. So with an OR operator, you're checking to see if at least one of these conditionals are true. Okay, so let's illustrate that with the code here. So I'm going to change this double and here. Let's change it to. And so now we're checking to see, only one of these things has to be true. So either the number that we're checking is an even number, or if the number is greater than 8. Okay? If either of those things are true, we're going to enter into the body of the if statement. And in this case, we're going to reset the value of the variable to 0. Okay, so let's try it out. Let's try it out with our current value for needs correction 2. So our current value for needs correction 2 is 9. Let's check both of these conditionals combined with the OR statement. The first thing we're going to check and see if 9 is an even number. 9 is not an even number, 9 is an odd number, so that first statement there is going to return false. Next thing we're going to check to see is if 9 is greater than 8. Okay. 9 is greater than 8, and so that second part there would return true. And so in this case, we have one false and one true combined together with an OR operator. And so in this case, this entire statement here is going to be true. Okay. And so since we do have one true, we're going to enter into the body of the if statement. And we're going to set the value to be 0. So based on this code, you can see that the final value for needs correction 2 should be. Okay, so let me run the code. And indeed, that is the case. And so needs correction 2 does end up with the value. Because we combine these with an OR, even though one of these statements is false, you just need one true in order to. All right, any questions on the OR operator? Okay, good. All right, so and ORs and if statements, going to be a central thing for us, Okay. It gets really screwy once you kind of start combining multiple ands and multiple ORs together in a single if statement. So let's say that you want to do this or this, or maybe this or this and another condition, right? You have parentheses in there to kind of screw things up a bit more. So the logic definitely gets pretty hairy sometimes. And so and honestly, I think I've noticed that it's started to get trendy. So I don't know if I'm just a big freaking nerd, but I go on like social media, Facebook, and I get snippets of code with like and or like a bunch of things. And they're like, what's the output for this code? And I guess it works because I engage with it. I stare at it for 10 minutes before deciding what to. So I guess Facebook knows me pretty well. But for us, we're probably not going to do anything too crazy like that. Probably most likely we're just going to have a single and or a single or. But it is important for you guys to know how to use ands and ors. Okay. All right. So that is, a pretty extensive kind of, overview of ifs, else ifs, ands, and ors. Okay. That's going to be kind of a central thing for us. Okay. Back to the slides. All right. So before we move on to for loops, there's one last kind of tool that we can use with our if statements to kind of give us a bit more customization, right? And so the last bit of if statements that we have are what's called else statements. Okay, so an else is a part of an if statement. Okay, but if you notice here, the else does not have any conditions, right? So for an if statement, else if statement, you have to have some kind of conditional to return either true or false. An else statement doesn't care about those. Okay. So for an else statement is, basically it provides like an outlet. It provides a if all else fails. And so if all your other conditionals return false within your if statement, then the else is something that is kind of guaranteed to execute at the end. Okay. All right. So the way to kind of read this is that, usually an else statement, you don't always have to have an else if, you can just have an if else, but you can have it with an else if as well, right? So the way to read this statement here, first thing we're going to check is condition 1. Okay. That's always the first thing you check with an if statement is always the first conditional, right? And so if condition 1 returns true, if it returns true, then you're going to do the work that's there. And remember, the way if statements work is that if one of the conditions or if one of the statements returns true, you ignore. You only move on to the next statement in the if statement if that condition returns false. So let's say that condition 1 returned false, and so if condition 1 returned false, we're going to this part of the code. Next, we're going to move on to the else if, and so check condition 2. And so if condition 2 is true, then we're going to do the work that's within. Once again, if condition 2 returns false, then we're going to ignore that part there. And then finally, we reach the else part. And so the else is if every other condition in the if statement return false, then we do just whatever. Okay. So this is kind of best illustrated with code. Okay, so let's make an example with an if else statement. Once again, I'm going to define my variable needs correction here. So let me give it a value 10. Let's start an if statement here. Okay, so first thing we want to check here is, let's put one conditional here. Let's check if needs correction is less than 0. If needs correction is less than 0, we're going to set the value for needs correction. Additional here, so let's check and see if needs correction is greater than 20. So if needs correction is greater than 20, we're going to reset its value to 20. But if both of those statements return false, right? And so you can kind of see the situation where these return false. And so if our variable here has a value between 0 and 20, both the if statement and the else if statement here are going to return false. Okay. And so if both of those statements return false, then we come down to the else, right? Remember, the else has no condition because it only executes if everything else in the if statement returns. And so if everything else returns false, let's set the value for needs correction to be fine. So the statements only execute if all conditionals statements return. If anything above it, if the if statement or the else if statement returns true, then we're going to ignore the else. Okay. One way that I like to think about if statements is that, every time you have an if, an else if, or an else, they each kind of represent one branching path for your program. But you can't walk down more than one path. You can only choose one, segment of code within the if statement to execute. Okay. And so if we run this code, let me go ahead and comment the stuff up here just so that. Okay, so when we run this code, you can see our value for needs correction is started at 10. Both the if and the else if statements in this case can return false. So the value for needs correction is going to should be 5. Which it already was that. And so you can see that, I'm going to hit the code, run a few more times just so you believe me that I'm. And so after you run the code, this variable needs correction. So let's see what happens when we modify. We change this from 10 to -10. And so if I update this, the value of needs correction to -10, okay. What we're going to see here is that we're going to enter this first part of the if statement because -10 is less than 0. Okay. So after doing so, needs correction should have its value updated to 0. It's going to ignore everything. Here, after I run the code, needs correction does indeed have a value. Okay. Okay, so else statements again are very useful. All of these if statement constructs are useful because oftentimes, when you write an if statement, there's usually kind of a default. It's usually called a default case. Some kind of default scenario where if everything else fails, then you still want to do something. That's usually what the else statement is. Okay, any questions on the else statement here? Okay, cool. All right, so that's conditional programming. So if statements, else ifs, else statements, ands and ors are going to be really centrally important to what we're. Okay. The other really essential part to optimization algorithms is basically some kind of way to repeat code. Now, there's 2 types of loops, and so you've probably learned, that there are for loops and while loops. For what we're going to be doing, oftentimes, for loops tend to be a little bit more useful. They're a little bit easier to control, mostly. While loops can get away from you if you're not careful. So the thing with for loops is that for the most part, your for loop something which is. Okay, so the idea with the for loop is that for loop is a way for you to repeat a set of code, many times without, take it all in. Okay, so the syntax for a for loop will come up. So start it with the statement for. You're going to define a new variable here called the loop index variable. And you're going to define the starting value for this variable and the ending value for that variable. And within the for loop, you're going to have some code here to basically and you're going to repeat this code for as many times as the loop is. So this is really useful because it's there's going to be a lot of algorithms where we need to do multiple evaluations of the objective function. And a for loop is kind of the most elegant and easiest way to do this. Okay, and the nice thing about for loops is that oftentimes we're going to make use of loop index variable. So the way the loop index variable works is that the loop index variable is the programmed way of keeping track of how many times you've executed this code in the for loop so far. Okay, so let's look at an example here. So one very common way to use a for loop is to visit every entry in a vector and to define its values. So if you remember from last time, we went over this command here called the zeros command. So the zeros command is a way to create an empty vector. And so in this case, we're making a vector that has 1 row and 5 columns. 1 row, 5 columns. And through the zeros command, we're going to, all of those entries in the vector are going to be 0. So first entry 0, second entry 0, third entry 0, fourth entry. So one way to use an if statement. So let's say that we want to, define each entry in the vector to be all the even numbers up until the end of it. want the first entry to be 2, we want the second entry to be 4, 6, and then 8, and then 10. The one way that we can do this is that we can use them. So let's kind of break down the anatomy of this loop. So you can see here that starting with the keyword 4. We have our loop index variable, and so you can call your loop index variable whatever you want, and so you're kind of free to name it's something that's convenient for your code. But for this example, I've named my index variable just index, okay? I'm giving it a starting value of 1, and so on the first iteration, the loop index is going to have that value of 1. I want it to go up to 5. So what's going to happen is that each time the loop repeats, the value for index is going to increase by 1, right? So it's going to go 1 on the first iteration, 2 on the second iteration, 3 on the third iteration, 4. Okay. And so this line of code here is quite simple, but there's kind of a lot going on, especially if you're not used to using index variables within. Okay, and so with this line of code here, you can see on the one hand, we're accessing the values in our loop vector. The loop vector, that is an empty vector that we defined just a couple lines prior, right? Right now it's all zeros, but we want to use the loop here to define every single entry in that vector. You can see there, you can see here that we're using the index variable of the loop. And so, if you remember from last time, one way to access entries in a vector, so we're saying loop vector parentheses index, right? And so, based on the current iteration of the loop, that's going to access, one particular entry of the vector. And we're going to set its value to be 2 times. Okay, and then the result of this code is like this. But oftentimes I think with loops, it gets a little bit confusing because I think you see the aftermath or kind of the ending result of the loop. But you never really see how that loop is kind of changing our data structures kind of every single iteration. So what I did. For this example here, I kind of listed out the logic here for that. Okay, so remember, when we first start this loop, we have a 5-element vector. Every single one of the entries in that vector is 0. This right here is what our loop index. But we've seen the end result. We know the end result is we end up with a vector that's 2, 4, 6, 8, 10. Okay. But that end result there doesn't really give you an idea of kind of what's kind of happening in each iteration of the loop. Okay. Because the loop actually is, it actually is repeating your code, 5 different times. And each time that it iterates or each time that it repeats, it's updating just one entry in that vector. Okay, so let's look and see what's happening with each iteration. And so on the first iteration, so this is the first iteration that's going to occur. Value for the index variable there is 1. That's what we defined as kind of the starting value for that index variable. Okay. And so all within that first iteration, then this index is going to be 1. So we come back to the logic of the itself. And so if index is going to be 1 here, then we're going to access the first entry in the vector. Set that equal to 2 times whatever that index is. So for the first iteration, index is 1. First entry in the vector to 2 times. Which is exactly kind of what we have here. So we can see we haven't touched the rest of the entries in the vector yet because that's but at least after one iteration, we have a value of 2 for the first. Okay. Any questions on this so far? Okay, good. All right, so then we move on to the second iteration. So after we reach the end of the loop, right, then we know that we still have more repeat to do, then we're going to return to the top of the loop. Then our index variable here is going to count up by 1. Okay, so instead of 1, it's going to have its value updated to 2. Okay. And so on the second iteration of the loop, our value for index is going to be 2. And we're going to perform the exact same line of code. The only difference is that, the value of index is different. So we're going to access since index is 2, we're going to access the second entry in the loop vector and set it equal to 2 times 2. 2 times 2 is 4. So our second entry is 4. Exit the loop at that. So our third, fourth, and fifth entries are 0 again. Still 0. And so on the third iteration, the value for index is updated. Okay. And so once again, we're going to go through the same thing. So we're going to update the third entry in the vector, set its value to 2 times 3, which is 6. Okay. All right. Fourth iteration, the value for index is 4. So once again, we're going to value fourth in the vector, set it equal to 2 times the index, which is 2 times 4, which is 8. Okay. And finally, for the fifth iteration, so you can see from our loop here that our loop is going to end when index is valued equal to 5. Okay, so that's going to be the last. That's going to be the last in the loop. So this is where the loop ends, and so we're going to access the fifth entry in the vector, which is the set its value to 2 times the index, which is 2 times 5. So that gives us our last entry of 10. Okay. Any questions on this example here? All right, so loops are also going to be a big part of our optimization algorithms. There's going to be a lot of algorithms that cause us to kind of repeat functions, right? And so you'll kind of see it in a bit. Okay. It's possible to have what's called nested for loops, and so for loops within for loops. I always think about, when I was little, I watched the show Pimp My Ride a lot, and so in that show, the host exhibit always says like, "Oh, we heard you like poker, so we put a poker table inside your car," and it's kind of become a meme. Whenever I think of nested for loops, like I heard you like for loops, we put for loops inside your for loops. We're not going to do too much of this. There's not too many algorithms that require a for loop, but it is technically possible to do. And so with this, then the code's going to repeat itself a lot. And so you can imagine that, for the inner for loop being this so many times, but then this for loop itself gets executed and repeated, multiple times because of the outer for loop. Again, we're not going to do too much on this, but it is possible. Okay, what we are going to do a lot is we're going to have if statements within for loops. Okay. Because a lot of times our algorithms are going to require us to iterate multiple different times and try out different guesses. And then depending on the quality of that guess, then we're going to do something or else. Okay. And the best way to do this is to use an if statement within a for loop. Right? So basically the logic here is that we're going to be repeating the set of code multiple different times. And then depending on the conditions within that for loop or the conditions at a certain iteration, then we're going to do something different that we're going to define. Okay. And so here's just a very quick example. And so let's say that, very similar to the last example we did, we have an empty vector, this time with 20 entries. And let's say that, we want to define the entries in this vector, but we only want to do it for the even numbered entries. Second entry, the fourth entry, the sixth entry, the 10th, so on and so forth. Okay. And so one way that we can do that is we can use our handy dandy modulus operator. And so we have a for loop here, our for loop index from 1 to 20. We're going to check to see if that index is an even number. Vector index, we divide by 2. If the remainder of that is equal to 0, then we set the value. If not, then we just completely ignore. Okay. And so here, this is the end result. So we have a 0, 2, 0, 4, 0, 6, 0, 8. 0, 10, 0, 12. You can see that all the odd number entries are skipped because of our if statement within the for loop. Then we kind of move on. So I have a couple other examples here. You know, these lecture slides are kind of more relevant. I kind of designed these lecture slides for my graduate level finite element course. So, instead of those examples, I want to do a couple kind of like, fake optimization algorithms, just so that you can kind of see a little bit of the structure in terms of how we're going to do it. But before we get into those examples, are there any questions on for loop? Just kind of anything we covered before? Okay. All right, so let's come back into MATLAB here, and let's kind of put this all together. Okay, I'm going to create a new script. I'll call this magic number. Okay, so if you think back to homework 1, so remember one of the problems within homework 1, I had you play a game with the partner. So I had you think of a magic number between 1 and 100, and I wanted your partner to kind of guess that number based on a few different algorithms. So that homework problem was a little bit premature. So, we didn't really do anything with that kind of logic in any of the classical method stuff. But that kind of thinking is going to serve us well for. So in this example here, I'm going to program that magic number finder. Okay. And we're going to do it in a few different ways. So we're going to do kind of we'll program a really dumb way to solve this first. And then, we'll do a smarter way. We'll do some smarter ways after. Okay. So what do we need for this program, right? And so this program, is going to guess a magic number. Okay. So let's define a variable. Find a variable. Hold our magic number. Right. But we need to know what our magic number is that we're trying to find. So we define a variable magic number. Okay. We give it some random number here. Let's give it 77. What's luckier than 1 7? It's 2 7s. Okay. So I know this is kind of a silly program because we're trying to get the program to guess the magic number, but we're also telling the program exactly what the magic number is here, which is 77. Okay. And so we're trying to get one part of the program to guess another part. Okay, so down here, we're going to write our algorithm for guessing. Okay. So what's kind of the simplest, kind of dumbest way that you can think of, to say that, if someone told you, just came up to you in the elevator and said, I'm thinking of a number between 1 and 100, you have an unlimited amount of guesses, how are you going to guess? So one very simple, dumb way that you can do that is you can start at 1, you can ask them, is the number 1? No. Is it number 2? No. Is it number 3? No. You just kind of keep going up until you guess the right number, right? So let's kind of program that algorithm. So we're going to write kind of a very simple, dumb algorithm for checking every single number from 1 to 100 until we guess the right number. Okay. So let's kind of read that statement there, and let's try to kind of devise a program going to kind of fulfill that objective. So we basically want to write a program here that's going to try to guess every single number between 1 and 1. So that seems like a very repetitive task. Very, very repetitive. And so anytime that you have a logic or an algorithm that is going to be very repetitive, you're just going to do the same calculation over and over, that's always a really big hint that you should use a for loop to program, right? Because it's very easy to write a program and say, yes, if yes is equal to number. Yes here guess equal to 1, right? Right, so you can just repeat this 100 times. That's kind of. So instead of doing that, let's write a for loop. To basically, do this repeat. Just to make this kind of repetition easier. Okay? Anytime you have to repeat code, for loops are kind of your goal. Okay, so we're gonna have 4. Right? We know that we want to repeat this 100 times, or at most 100 times. Okay? So we want our for loop to repeat 100 times. So we have 4 index is equal to 1. Okay. Don't forget the end, right? So anytime you have a for loop or if statement, remember to write the end at the end. So if we look at the anatomy of this for loop here, we have our loop index. We're going to start this loop at 1. And the last value that we're going to check is 100. Okay, so that's a great start. So that's kind of a good skeleton in terms of getting us started with the program. Next thing that we're going to have here is that I want to make a variable here that keeps track of our current. We're going to be guessing every single number from 1 to 100. Right? So we can have a variable that kind of keeps track in terms of what. Okay, so I'm going to define a variable. And once again, you can kind of see here that I'm using very kind of descriptive names for the variables, right? And so I'm going to initialize this variable current underscore guess to be a value of 1. Know that we're going to start with a guess of 1, and then we're going to go up higher and higher and higher until we reach it. Okay. And so basically within the for loop here, we're going to check and see if our current guess is equal to the magic number. If it is, then we're good, then we can stop. If not, then we keep going. Okay. Inside our for loop. Check. Is, then we can stop. Okay. So if you notice here, I'm writing out every step in the algorithm so far in words. Okay. Remember what I said last time that programming is nothing more than just communicating with your computer, instructing the computer to execute a certain amount of tasks, or in our case, we're instructing the computer to execute a certain algorithm. Right. And so I always find it helpful. So for me, whenever I'm programming or I'm putting something up in Python or something like that, I always have a notepad next to me, and I always think about what is the intent of the program to execute right now, and I write that down on a piece of paper. Okay, and then I take that paper and I say, okay, how do I translate this human instruction into code that a computer will understand? Okay. So you can do this in the comments, and so I think that's kind of the best way to use comments in a programming language. But I want you guys to kind of get in the habit of kind of writing out in Word what your algorithm is trying to accomplish. And it sounds really silly. I know it's you're not going to want to do it, but trust me when I say that if you kind of get into the habit of doing this, it's going to make your logic, it's going to make your programming know what you want to accomplish. And then from there, it's just kind of finding the right syntax or finding the right programming constructs to accomplish. Okay, so now let's take this statement here and let's write the code. Okay. So based on the statement here, we can see that we need to perform a check. Okay. So anytime that you have a check, that's usually a good indication for you that, you should probably have an if statement in there. If statement is the best way to check whether something is true or not. We have if. Okay. And statement as well. Okay, so the thing that we want to check inside this for loop is that we want to check to see if our current guess matches the magic number. Okay. And so the way that we can code this up is say if our current guess is a variable that we have, if current guess is equal to magic number. So if current guess is equal to magic number, then that's true. Okay. And at this point, our guess is correct. Since the if statement return. We'll talk about kind of what to do within that if statement in a second. But if it's false, okay. Remember, one thing that we can do to execute kind of a false, if our condition is false, is to write else. Okay. If our current guess is false, then what we want to do, then we want to keep going, right? So we want to guess the next number after the current. So we're going to redefine a current guess variable here. In particular, we want to increase its value by 1. Okay. So if our guess is correct, then we're good. Then we can we can stop. If not, then we move on to the next one. Okay. Okay. There's actually a key word here. Okay, so if our current guess is true, then we don't want to guess any more of that. We've already found the magic number. And so in order to kind of stop guessing, we need to break out of this for loop, because this for loop here is kind of pre-programmed to execute 100. But if we find the magic number, before we reach 100 iterations, we want to stop because we don't want to keep going. There's another keyword. This is probably one you've probably seen for loop. But break is probably something that you haven't seen before. And so break is kind of a special keyword in MATLAB, where if you execute a break statement within a for loop, then once the break statement is encountered, then it literally breaks out of the for loop, and so it stops all future iterations of the for loop. If break statement is encountered, all future iterations of the for loop and exits. Breaks. Okay. And so with that break statement, once we guess correctly, then we can break out of that for loop and just kind of move on. Okay. So this is it. So this is our first optimization algorithm. Now, granted, it's a very dumb algorithm, right? And so it basically just guesses dumbly until we get the right answer. That's certainly one way for you to do an optimization. Okay. And with the power of computers, and for fairly simple problems, that's something that you can do. So let's run this and kind of see what happens. Okay. So our magic number is 77. Okay. So if we wrote this program correctly, then by the time that this program finishes, then our current guess should match our magic number of 7. Actually, let me do this. Let me clear the workspace there. Okay, hit run. So after I run the code, you can see that our magic number variable is 77. And our current guess, head back. So the magic number is 77, and our current guess ends up with 77, right? It stayed at 77 because once our current guess matched the magic number. Okay. Any questions on that? Okay. Good. All right. That's our first algorithm, right? So it's very much, this is kind of just guess and check, right? And actually, you'd be surprised that randomly guessing and checking is actually a legitimate algorithm. It's not a very good algorithm, but it is actually legit. People actually use it. It's called Monte Carlo. So we'll be talking about Monte Carlo a lot, kind of once we start to get the multi-variable strained optimization, later on in a few weeks. But in the world of optimization, modern techniques, really taking advantage of your computer and making it just guess a bajillion times is actually an effective strategy. All right, let's modify this algorithm here. So this was kind of a very dumb example where we're trying to guess a number that we already timed, right? Let's kind of update this algorithm to be a bit more kind of closer to what we're doing. And so in optimization, we are given objective function. Okay. So let's rewrite this program to instead. Let's write a program. Okay, let me make a new program. So this here we'll call this guess and check. So in this example, we're going to write a program. Find minimum of objective function by guessing a lot of values, finding the most minimum. Okay. So it's going to be very simple to the last program that we wrote, except we're going to have an objective function. Right. Okay. So the first thing that we need to do is we need to define our objective function. Okay. And actually, we need two things for this objective. Okay. So the first thing we need a vector that defines all possible values of the design variable. Because remember, our objective function here is always the function of our design variable. So we need a vector to keep track of that. Okay. Okay, so for this, right? If you remember from last time, we went over a special function called linspace. Okay. So linspace is a special function here that creates a vector for you, which has entries from the starting point to the ending point with the specified number of. So in this one, let's say that I want to search within the space of between 0 and 10. Okay. I'm going to say x is equal to linspace between 0 and 10, and I want 1,000 entries between. Let me show you what that looks like. I don't think I did an example with linspace last time. Okay. This space function below the vector 1,000 entries. First entry 0. Entry will be 10. All other entries will be 10. Okay. All right. So this is kind of where the power of computers really comes into play, because if you're going to check every single value of x between 0 and 10 with 1,000 different guesses, that's kind of impossible to do by hand. Okay, so let me run this code so you can see what it looks like. Okay. If I run this code, you can see that we have a new vector here, x. Okay. If you look at the entries in x, you can see that the first entry is 0, the second entry is 0.01, 0.02, 0.03. So it's literally every single entry between 0 and 10, and it does it by increments of about 0.01. So if you're going to check every single one of these values by hand, this is kind of impossible. Okay, so that's the first thing that we need. Second thing that we need is we need a variable here that defines our objective function values. 2, we need a variable evaluates the objective function, all possible values of the okay. Okay. So we're going to have a function f here. Okay. So for the objective function for this example, it doesn't really matter all too much. So let me go ahead and just do x 7 times x cubed minus 14 x squared plus x 28. Okay. We only like 7 state entries up. Okay. Okay. And so if you notice here that I've used the dot operator, so whenever you have an exponent or a vector, you want to do the dot operator. And so this is the objective function that we want to find the minimum. And so we're going to do this by brute force. So we want to check at every instance the design variable and find the minimum. So traditionally, if you were to do this with the classical methods, you would take your objective function, you'd find the derivatives, you set it equal to 0. Okay. That's kind of the elegant way to do this. Okay. What we're doing here is kind of the brute force method of just check every single one and then just find the minimum. Okay, so just like our previous example here, we're going to write a for loop. Okay. First, let me say our current guess. We need a variable here to define our current guess. And our current guess in this case is going to be the first entry of our x vector. Okay. So that's x of the 1. Sets. So this sets our current guess to be the first entry in our design variable vector. Okay, next thing we need a for loop. We need this for loop to repeat 1,000 times because we have 1,000 guesses to evaluate. Okay. Okay. So what we want to do, just like our magic number code here, is we want to check if our current guess is better than our previous best. Check our current guess anytime we have a check, we have an if statement. Okay. If we need one more variable, sorry. So we not only do we need the current guess, we also need the current value of the objective function at that guess. So the current guess value current that value if f at index. Okay. So if at that index is the kind of the check of the current value of the objective function at the current part. If that is less than current F value. Okay. Right? And so if our current guess is better than our current best value, okay, that means we found a better point. So if we found a better point, then we're going to update our guess. And okay. I'm trying to rush here, just I'm trying to finish, but we'll go over this again after the midterm. Okay. So say that current guess equal to next, and then we'll say that current value. Okay, and so in this case, we don't, a little bit different from the last example, we don't know if we reached the global minimum, so we have no choice but to kind of check every single one. Okay, so let's run the code. Okay, and so if we wrote this code correctly, then our value for the F value should be the minimum. Okay, so we actually kind of end up with a silly result here. So it looks like our best value is actually the origin. So x is equal to 0, and it has a value of -28. All right, we'll come back to this again. So I kind of made this example up on the fly, so I wasn't sure how. But we'll go over this again after the midterm. All right, any final questions on this before we wrap it up for today? Okay, all right, so I will see you guys on Thursday for the midterm. Remember, I have 2 more office hours before the midterm exam, so I have office hours tomorrow at 5:30, and I have office hours on Thursday at 1 o'clock. So definitely feel free to come by if you have any questions. Okay. So thank you guys for coming today. I'm sorry this last example was a little bit rushed, but we'll pick this up again once we come back after the midterm next Tuesday. Best of luck studying, and I will see you guys on Thursday. Do you get a cheat sheet? Yes. And so you have one 8.5 by 11 sheet, both sides. Yeah. Okay. Yes. Still do. You could, well, so if you do direct sub, it depends on whether you reduce the problem to if you're able to reduce it to a 1D problem, then you can just take and so you take the first derivative set equals 0. That finds you the option. And you take the second derivative, and or you got it. So exactly. So if it's that happens if you have a linear function. So if you have a linear function, so you take the derivative once and end up with constant. And so for a linear function, x and n is going to be at the extremes of the shrine. Think about a linear function, it just goes like this. Exactly. Yeah. So usually, so if it's an unconstrained problem, usually you shouldn't get a linear objective in that case, but then if it's unconstrained. I'll just kind of surprised at this. Saying like, oh, this is. Yeah, so but if you have a constrained problem, then you can have a linear function that's going to do whatever the extreme of it. So I wanted to ask. Thank you. Yep. So solve it just the same. Yes. Exactly. Yeah. Yeah. That's true for any multi-variable section. You can choose direct sub or direct sub will work 95% of the time. There's a few kind of niche problems where So I think problem 3A or 2A. You needed to, get us, you need to get a situation where you can set one of the variables. But in most cases, the rec cell will. Hey,
I was trying to do, I know you don't put the solution for the Cs for 2 and 3.
yeah, I know, I updated that, so it's there now.
Okay, yeah, so. Yes, I started doing half of what. It's like,
So your constraint here, so it should be W squared plus H squared is equal to 2R squared.
oh, there we go.
Yeah, because R is just the radius, but then if you drew the whole down
Yeah.
to 2.
Okay, yes, thank you.